morning everyone, Mr. Lesham is here and we're still carrying on with trig, and this is our last lesson before the test, okay, and I think you'll find it a little bit more friendly than the identity ones. We're not giving up on identities, we're still using identities, and now we're using them. It's kind of like a wedding. We're doing a wedding between the identities and the, what do you call it, this reduction formulas, the simplification expression terms. So what is our aim, okay? We're going to get an trig expression. That's called the trig expression. There's some trig in it, okay? It's not an equation, okay? It's not equal something. What we are instructed to do is to simplify. Now, that looks very similar to what we've done before identities, and you were actually quite good with that. So let's start with it, all right? Hopefully you remember something, okay? So sine 90 plus theta. When I'm adding 90, what am I actually doing? You remember what happens to sine? It becomes cosine, okay? So sine 90 plus theta, that becomes cosine theta. Then we have to decide is the plus or minus, okay? Because 90 plus theta, we're living in the second quadrant. The sign is positive, so it stays positive. So I can just write that as cosine theta. Okay, I know it's kind of, you don't remember it exactly, but you'll look at your notes and you'll remember it. You're quite good with that. Tan 180 minus theta, okay? So that's something to do with tan theta, okay? But I don't know if it's plus or minus. What do you reckon? Moving from the first quadrant, 180 minus theta, okay, if you remember, okay, let me put that. If this is theta, that will be 180 minus theta, okay? That will be 180 plus theta, and that, remember that one, that's 360 minus theta. Okay, so what happens to, should it be minus or plus here with tan? Tan is minus. Tan is plus here and here, but here it's minus. So I'm going to multiply it by minus tan theta. Why should I put the brackets? What happens if I don't put the brackets?
Otherwise you just...
I was just like saying...
It looks like cos minus now, which is not. It's cos time minus. Okay, now I've got 720. What do I do with 720? It's 360. Okay, so what is 720? Expert in numbers, Bruce. In terms of 360, what is 720?
2 revolutions.
So it's exactly 2 revolutions. So I can take them off. I don't have to only take 360. I can take 720. Because adding another revolution, 1 revolution, 2 revolution, 3 revolution, as if I didn't do anything. So I can straight away take that as sine theta.
Can't you change it?
Right? Are you happy with that? Okay? Right, now, this is where we would have stopped when we learned about reduction. Because there's not all it's all reduced, okay? I'm going to take the minus out. It's minus cosine theta tan theta. I'm just putting the minus in front. Divided by sine theta. There's nothing else I can do. Now kicks in the identity. What should I do in terms of identity? What can I still play with identity? The tan. The tan is sine over cosine. So we're going to write as minus cosine theta over sine theta times tan. What is tan? Tan is sine theta over cosine theta. See, I took him out. I can take them out. Can you see why I've done that? What do I do now?
You get a
cross cancel.
Everything cross cancels. What's the answer?
Negative 1.
Not forgetting the minus here. Okay? Negative 1. Okay? So we basically are working, as we work with all the reduction formulas, which is a lot to remember, and the last step we actually use the identity tan equals sine over cosine. That's pretty easy. I'll just pause. Okay, so here's the next one, which we're going to use another one of identities. You can probably guess which identity it is, one that we haven't used yet. Okay, but we start with simplifying. Instead of sine minus x, what can I write? What happens to negative angle to sine?
It gets put into the fourth quadrant.
Okay, what does happen to a sine when I'm going minus x? That's minus theta. What happens to sine here? Is it plus or minus? Minus. So I can write, instead of sine minus x, I'll write minus sine x. Cosine 90 plus x. Okay, whenever I'm adding 90, that's a co-function. So that's going to be sine x, but is it going to be minus or plus?
It's going to be minus.
It's going to be minus.
Yeah, minus, because cos is minus in the second.
Yes, in this case it's going to be minus because you're right, cos in the second quadrant is negative, okay? Yeah, that's very important. Now I've got cosine 180 plus x. What happens when I'm doing 180 plus x to cosine? Should be standing. Okay, I've got this one. It's going to be something to do with cosine x, but is it going to be negative or positive?
Negative.
It's going to be negative because positive is negative here. So I've got a double minus here.
Oh no.
We don't like double minus, eh?
It's fine.
Fine. I think it's fine. I had that minus to begin with, but now the cosine 180 plus x became negative cosine x. And then finally cosine minus x. What happens to cosine negative angle? Is it positive or negative?
It's positive.
It's positive. Positive is positive there. So it's cosine x.
Okay.
Okay, let's write it neatly. Minus sine x times minus sine x is
Positive
sine
squared.
squared x. Negative negative will be plus cosine squared x. Now when we learn in reduction, hang on, there's a question there. So when we learn how to simplify and reduce these, this is where we'd have stopped. But now with our power of identities, we can do one more step. What is going to be the last step? What is that equal to?
It's 1.
It's 1. Okay, that's our second identity, which actually is not written here, but if you just move the sign square out to the other side, you'll see it.
Can also
Okay, so like I told you before off the camera, let me just say it again. In the test, you're going to have a whole bunch of expressions, and I'm going to ask you to simplify these expressions. Most of these questions will not have identities in it. You're not going to have to use identities, but some of you will have to. So you need to be aware that you might have to use some of these identities. Okay, let's pause here. One more. We want to simplify this expression. The sine and cosine, I think it's okay. What about the tan? What's the first thing? Because we never really worked with tans in these simplifications. We don't know what happens to tan.
Yeah, it will change, really.
It stays, what you call it, stays positive.
But it is with 90, so there's some kind of confaction. So I don't want you to...
It's a positive.
It is, in fact it is, but I don't want it to go there. So what's the first thing you do when you get a tan?
Sine, cos.
Exactly, we're going to split into sine 90 minus theta divided by cos 90 minus theta. And each one of those I can do. In fact, Simon, if you heard him, he actually gave us the right answer, but we're going to go the long way around. Okay, so that I replace with it. Sine minus theta? Minus sine theta. Okay, sine becomes negative with negative angles. And I'm putting a brackets here. Those were brackets. Remember, we're not minusing, we're multiplying that. Okay, divided by cosine 180 plus theta. We had that already here earlier. It's minus cosine theta because in the third quadrant, cos become negative as well. We happy so far?
Yes.
Okay, now we got to deal with these guys. Co-function, right? What do I write instead of sine 90 minus theta?
Sine theta.
Cos theta. Okay, that's function. So whatever you have, 90 is basically, you change it, okay? So cosine 90 minus theta will be? Sine theta. Okay? And then I multiply. Can I put the minus there? I'm just putting the minus on the other side. Would you mind if I do that?
Yes, that's fine.
Okay? And here I've got minus cosine theta. And then everything becomes very easy. What's the next step?
Can you flip and turn?
Before I flip in time, there's something cross cancel. Let's cross cancel as we speak. So what we get is minus cosine theta divided by minus cosine theta. And you're right, the answer is 1. Okay? So here, this example was where before we did the reduction formula, and the last step we used the identity. Here, in fact, we had to use the identity to begin with. Okay? But as you can see, I think you'll agree with me, the identity part here is not difficult. It's not like the hectic stuff you have to go from the left hand to the right hand side. We've got simple identity rules to use here. So I think you should get these marks. Right, I'll say goodbye here. Let's do some work. Bye-bye.
Bye.